Hello, this is Dr.S.Selvalakshmi, Assistant Professor of Physics, the Standard 5X Rajaratnam College for Women, Sivakasi. In the previous video, we were seeing about the introduction to fuel cells. And in this video, we are going to see about one of the classification of fuel cell which is based on electrolyte used in the fuel cell. And the topic of this video is alkaline fuel cell. On seeing this video, you will be able to know the history of alkaline fuel cell, describe the working principle of alkaline fuel cell, analyze the advantages and limitations of alkaline fuel cell, and identify the applications of alkaline fuel cell. Alkaline fuel cells or potassium hydroxide, in alkaline fuel cells potassium hydroxides are used as electrolyte. The alkaline fuel cell is the first generation fuel cell system that was employed for power resources in space vehicles. The alkaline fuel cell is one of the most developed fuel cell technologies and is the cell that flew man to the moon. Let us now see the history of alkaline fuel cell. Alkaline fuel cells were the first practically working fuel cells capable of delivering significant power, particularly for transport applications. The pioneer working of Francis Thomas Bacon in 1930s at the University of Cambridge led to several significant advances and innovations, especially the development of porous sintered nickel electrodes. Bacon demonstrated the first viable fuel cell power unit in the mid-1950s. This system was the starting point of a new technology using alkaline liquid electrolyte, which led its use as the electrical power source in Apollo missions to the moon and later in the space shuttle orbiter. This system was developed and studied extensively throughout the 1960s to the 1980s prior to the emergence of the proton exchange membrane fuel cell, which has subsequently attracted most of the attention of the developers. Now let us see the components of alkaline fuel cell. The alkaline fuel cell consists of two electrodes, a positive electrode and a negative electrode, and the negative electrode is a porous nickel anode and the positive electrode is a porous silver cathode, and it has a gas diffusion layer, and then the electrolyte used here is potassium hydroxide, and it also has a load to complete the circuit. And this alkaline fuel cell should be supplied with a continuous feed of fuel and a feed of oxygen. Let us now see the working principle of alkaline fuel cells. This cell works optimally at 80 degrees Celsius using relatively inexpensive material. A single alkaline fuel cell consists of two porous electrodes with liquid potassium hydroxide electrolyte between them. The hydrogen fuel is supplied to the anode electrode while oxygen from the air is supplied to the cathode. Voltage between the anode and cathode of a single fuel cell is between 0.9 volts and 0.5 volts depending on the load. The working principle of alkaline fuel cell. Hydrogen atom which enters into the fuel cell at the anode where a platinum cathode is present, it reduces the hydrogen to splits the hydrogen into positive hydrogen ions and negatively charged electrons. The positively charged hydrogen ions react with the hydroxyl ions in the electrolyte to form water. The negatively charged electrons cannot flow through the electrolyte to reach the positively charged cathode, so they must flow through an external circuit forming an electrical current. Oxygen enters into the fuel cell at cathode and picks up the electrons and then travel through the electrolytes. The anode electrolytes to the anode where it combines with the hydrogen atom. Oxygen with electron combine hydrogen at anode and form water which drains from the cell. So this is the functioning of alkaline fuel cell. At the positive electrode, oxygen, water and the returning electrons from the external load combine to produce OH minus ions. So half molecule of oxygen reacts with water and two electrons to form two hydroxyl ions. These ions migrate from the cathode to the anode where OH minus ions combines with hydrogen to produce water. An equivalent number of electrons are liberated that flow through the external load towards cathode. So, hydrogen and 2 hydroxyl ions reacts to form 2 molecules of water and 2 electrons. So, the fuel used in this AFC must be free from carbon dioxide. So, AFCs, these are the advantages of AFC. AFC are the cheapest fuel cells to manufacture because the catalyst required for the electrodes can be any of several different chemicals that are relatively inexpensive compared to those required for other types of fuel cells. The AFCs have the highest performance among all type of fuel cells. The rate at which the chemical reaction takes place in this cell is very fast. AFC is of low material cost because plastics, carbon based metals and metal oxides are used and less amount of platinum is used. The long lifespan of AFC is much appreciated and it has 2000 plus hours currently. It works continuously for 2000 plus hours. It is the superior electrochemical conversion efficiency compared to other fuel cells and the internal combustion engine. It has a quick start even in sub-freezing temperatures down to minus 40 degrees Celsius. It is the simpler heat and water management when compared to other fuel cell technologies. Like other fuel cells, it is odorless and quiet for enclosed applications. Let us now see the limitations of AFC. AFCs are very sensitive to carbon dioxide that may present in the fuel or air. The CO2 reacts with the electrolyte, poisoning it rapidly and severely degrading the fuel cell performance. AFCs are limited to closed environments such as space and undersea vehicles and must be run on pure hydrogen and oxygen. AFC stacks have been shown to maintain sufficiently stable operation for more than 8,000 operating hours. To be economically viable in large scale utility applications, these fuel cells need to reach operating time exceeding 40,000 hours. Now let us see the applications of alkaline fuel cells. The alkaline fuel cells are used as power sources for vehicles such as fuel cell taxi and boats. It is also used as power sources for rockets and spacecraft. They are used in generators and golf cars. So, the alkaline fuel cells must be free from carbon dioxide, and this is the main limitation of AFC, and this limitation can be avoided such that pure oxygen can be supplied as oxidant. So, this AFC is the best performing fuel cell. So, let us meet in the next video. Thank you.